The plastic challenge now has a new ally, the plastic detector sensors using metalenses. Dr. Rasoga and her Norwegian and Romanian partners are working in the ElastoMETA project, aiming to apply forefront photonics and nanoscience research towards the environmental issue of plastic waste, requiring novel sensor solutions. The knowledge gained from the project will be a competitive advantage for the plastic detection industry towards developing a smaller and more cost-effective sensors without compromising on performance. Keep listening to Research in the Spotlight to find out why such a project is necessary for the Romanian and European society.
What is your project about in a few words?
My project is about to create metalenses that can be integrated in optical sensors in order to sort the plastics. The purpose is to make devices that are cheaper and that can be placed near the people houses and so on. It's like decreasing actually the scale of the sorting machines that currently you can find in worldwide that are big and very expensive.
How important is the plastic threatening to the environment?
One person is searching on the internet will find a huge amount of companies, huge amount of countries that are speaking about this problem. For example, on the coast fields, actually for the moment it's like 35 kilometers tons of plastics. It's a huge amount. Actually the plastic is everywhere now. And they are trying to solve this issue. It's like there are more molecules that you can find in the water. They are the bottles that you can find on the landfill. In short of speaking, it's at the current time, it's like more than half of the percent, 50% of the plastic, it's still just thrown. It's not reused, it's not valorized in other things. It's like at the moment we are still working like a linear economy. It's like we are taking, making and just throwing. The interest, the global interest, and even for the European is just to go further to the circular economy. Our goal in ElastoMETA is like my partner was saying that a part of the plastic, the big developed country want to eliminate the poverty, but still the world to increase. It's like we are giving birth. The number of the population is increasing. To eliminate the poverty means that everyone have to have some commodity. Now you cannot live without the phone. You cannot live without the light. You cannot live without anything. It's and if you think the phone has plastic, the light has plastic, everything has plastic. If we just stop for a moment and look about in front of us, we are seeing that everywhere is plastic. The goal is just to make this sorting very easily. One of the issues is that, okay, we are liking to drink coffee from yellow, red glasses, the bottles for the detergent and so on, they are colored. The issue is that actually these additives are making very difficult the plastic sorting because each additive have different properties and you have to, to put it together, the transparent one, the red one, the white one and so on. And yeah, it's quite difficult.
Currently you are involved in a collaborative research project funded under the EEA grants. How did the idea of your project come about?
The idea of the project, it's quite simple. Actually, my specialization is in organic materials, in photovoltaics, organic solar cells. Still it's green energy. And I searched for partners. What I could know, it was just that I know to do nil. I know to do nil, I know to work with organic materials and just search for a partner. I find a partner who wanted a person who that is using nil. We start speaking. Actually, he was more on the theoretical part. He was working with the metamaterials. I didn't know about the metamaterials. It's not my domain. After 1 month to just, how to say, for both of us to be happy with the chosen, we choose to go with his scientific part and my experience in nil. And from here we end up with these metalenses for sensor detections, for circular economy, because they have expertise. Let's see, I have various of samples and tentative and research. Something like this. This is on glass. Same squares. And this is actually that is applying to nil. There are lots of trials. It's like current state. The first trials are ending like this or like this. They are having imperfections, bubbles, polymer. It was the first time, but we managed to. These are actually just for view. The ones that are clean are keep it in the clean room. It's like are in separate boxes. They are also here. I don't know if you can see the squares. And even another type of patterns. These are much smaller.
What are the research questions of your study?
Research questions, it's starting from the photonic theory. If you can find some meta surfaces, because actually these meta lenses, they are actually some meta surfaces with different designs and different properties that they make them meta lenses that can be tunable. The question is if we can make such a lens, if we can add it in a detector. Actually, I'm very positive with my partner. Another issue and a research question that is quite hard to ask if we are managing to do these lenses in a polymer. Because actually the goal of this project, apart of giving the lenses to the industry, is just to embed that tiny square that we are seeing, and you saw it, in a polymer. Means just pillars in a polymer, and it's quite difficult at this scale, small scale. But I think we can manage. And actually these meta surfaces for the people, I think they are more interested at changing the parameters and the design. They can make even the so-called invisible coat. It's at this stage the theory is capable to give results about the invisible coat. I know that they are existing now for the military purpose, but they are just like, if you are seeing me and I have that invisible one, you cannot see me, but also me. I cannot see you. The metamaterial can make this. I can see you, even you are not seeing me. It's just playing with the properties of the light, and it's quite interesting.
Are there any partial results that you would like to share with us?
Like I showed you before in the yellow room, we have some lenses made by e-beam lithography that are already published. We have some lenses made by Neil. Also, they are published in a paper. Still, the efficiency for my Neil it's quite low. It's like for the EBM metalenses, we are reaching 45, 40. With the Neil metalenses starting from 40, we are reaching just 6% for the moment. The issue is that actually I am using stamps made by 1.2 micrometers high pillars. That with my type of device, it's actually very difficult. Even the vendor said to me, and they are saying that I have to use smaller pillar high. But also my partner from Norway, was doing also some nail, and he was capable to do with the flexible stamp. Means it's much softer than mine. I'm using glass. It's reaching also almost 40%. Actually, the low efficiency, it's like 40, is not 100, is because we are using silicon. Normally, we have to have the pillars on glass. If you are like this, you can reach 100. The theoretical limit for us is 60. Means even though we are reaching 45 from 60 theoretical limit, and I think it's quite nice. This metalenses, it's made to be in the composition of the detector. It's still using it's still an optical detector. It's like the common principle of the optical detector, but instead of the diffraction lenses, you put these lenses. It's like one can think about that each type of plastic have a fingerprint, like we want to say. It's like if you go with infrared light, you will obtain some signals. For each plastic, you have different signals. These lenses is helping the light to pass between the plastic, and just to make this conversion, to help to decelerate between the signals of the polymers. The thing is that it's much smaller than the normal ones, and if we can apply this at the industrial level, it's becoming much cheaper, and the sorting machines we can find everywhere.
How the pandemic influenced your work so far?
The COVID pandemic actually starting, if I'm not mistaken, in 2020. Means my project was founded in July 2019, and I couldn't, due to the COVID, actually my partners couldn't come to Romania to help me with the setup of measure the lenses. I needed again to start from scratch by WhatsApp, by Zoom, by meetings, to learn how to do the setup by myself, and to start measuring. Also, the part that was much difficult, we just sent the samples in Norway. One of the issues is that I couldn't travel. I wanted to learn more about the NIL and more about the metalenses. There are lots of people who are doing. I follow some seminars and Zoom meetings, but I could not go. Another issue is that the workplace, we have limited number of people. We can be maximum 2 in the room and on shifts. But it was easy. It's like our director have said that if you don't have experimental work, you can work from home, and who has experimental work can come. But the problem is that the prices for the materials have increased. It's like even triple, and we estimated the budget, and then that budget we are seeing that it's not good anymore. Also, even the partners have limited time of working on the experimental part. It's like we somehow decrease the time of the experimental doing, or just we have to adjust the program for each part. If one is saying, okay, I can work on June, or I don't know, I have to think, how can I make the samples near him? That is quite difficult, because the samples, I told even before, the period of time is like 3 months expiring.
Your research is part of a collaborative project which involves an international research team and a partnership with a prestigious research organization from Norway, SINTEF Minia Lab. What does it mean to you and to the team you coordinate such a partnership, and in fact, what are the benefits?
For me, was a way to do something. I have the opportunity to, to learn how other people are doing research and how they are acting. It was the first time after my faculty that writing the project, because I can say that this project is equal mine and my partner, Christopher. We wrote both, and we spoke a lot during the night, during the day, tone of phones. It's like I was having the feeling of demonstrating who is the best. It's like a better way of speaking, of fighting to go further. It's something that is, at some moment I lose in my life, and it was quite beautiful. The experience of learning with people, because we start 2, we end up to deposit project on 4. We have another 2 Romanian partners. I think this project, it's one cannot do something without the other one. Okay, maybe just the Norwegian partner, but the Romanian people, I think we are interconnected. But even with the Norwegian partner, he has the design. I think the ideas and all the discussions are helping even him.
What are the next steps of your research?
The next steps is, like I said, we want to embed these patterns. We want to make the lenses very flexible. In scientific terms, it's like tunable. Means according to the stretching of the lenses, we can change the properties of the lenses. And to see that maybe can be applied in the industry. And I don't know, maybe we have some ideas to apply these metamaterials even on my starting domain in organic solar cells.
What do you think would be the social impact of your project?
Actually, what we are trying to do, we are trying to do a sensor that it's quite cheap, it is small, and also it's from materials that cannot harm people. It means we are trying to use green technology, and I think one of the impacts that we are not polluting more the atmosphere. The other, we are we are using silicon, but small amount of silicon, not a huge amount of silicon. And also with this type of sensor, I think we can eliminate this part of the plastic that can help the people. And I don't know, a better life.
In the end, after listening to this interview, what do you think people should remember about your research project?
They have to remember that plastic is a problem. Don't waste it. Think of other way of using, not plastic, but also they have to remember that there are people in the backstage, not just my project, but even in other countries, that are fighting to solve the sorting issues of the plastic in such a way that the people not lose their comfort, still living like they want, but without ruining the planet.
Dr. Rasoga, thank you for having us today in your research laboratory. I can't wait to see the final results of your project.
It's my pleasure that you came. I'm hoping you are not feeling too hot. No. And I hope that you can now feel what means like 3-4 hours working on the project.
Thank you for watching Research in the Spotlight, a podcast for scientists and passionate science people made under the EEA Grants Research Programme by the Executive Agency for Higher Education, Research, Development and Innovation Funding as program operator. Until the next time, like and share this episode if you think science is our key to a better future.